Here we go with the video segment 1 for week 1. Going to basically go over the history of the atom. It follows along chapter 4 in your book, and this will be section 4.1 when you go through stuff. We start with the Greek philosopher Democritus, who's basically one of the first ones to give us the idea of the atom, that it's the smallest thing that still exhibits physical and chemical properties of that substance. He coins the term atomos, which ends up being Greek for indivisible. And in doing so, he's the first to really suggest the idea of the atom. The problem is that's about 400 BC. Less than 100 years later, Aristotle comes along and changes everything. He's the one that basically comes around and says, there's only 4 elements of nature, and that would be earth, water, fire, and air. And he actually wins out over Democritus for the idea that he was more well-known. He did a lot of other scientific things that we talk about in physics. So people start believing him, and that's really the end of it for the next couple hundred years. So Aristotle kind of puts a halt to the idea of the atom and the fact that it is indivisible, it can't be broken down. It's not really until the late 1700s that we get John Dalton to come along, who basically uses scientific ideas in experimentation and hypothesis to come up with the idea that the atom is the smallest particle you can have. And he comes up with really the first atomic theory, and then it gets revised by everybody else that we talk about throughout history. But in his atomic theory, he comes up with basically 4 postulates. The fact that all matter is composed of tiny particles, which he called atoms, giving rise to Democritus's idea of the atomos, so he gives credit and calls them the atom. He says that they are identical. They are fundamental properties of the element itself. They always contain the same ratio of atoms, and also that in chemical reactions, atoms themselves can't change. So basically, it's a conservation of mass, that mass cannot be created or destroyed. And basically is fairly spot on when it comes down to the as far as 1700s, 1800s. Now we do know that the matter can be broken down into smaller pieces, subatomic particles. We do know that they're not all identical. There are isotopes which are slightly different from each other, but for the most part, for being 1800s, it's pretty spot on. Excuse me. Then we get to the idea of the fact that we do divide the atom up into smaller pieces, and that comes from J.J. Thomson. He's the one that gives us the electron, and inside the electron, the fact that he had negative particles. And basically, by doing so, he comes up with an experiment using cathode rays. Now, cathode rays are basically like a vacuum tube that he filled with different gases. In doing so, by putting an electric charge or a battery through it, hooking to a battery, he was able to see that the electrons or these particles were affected by charges. So he had a negative and a positive charge, and it was attracted to the positive side and repelled from the negative, which told us that those particles were negative in nature. Basically, a cathode ray tube is just like the old TVs. When you say you're watching the tube, back of those big TVs used to have lots of these cathode ray tubes, and they'd light up at different times and give us a picture. So it really is the advent of the TV that we used to know growing up. So a couple of things that he was able to tell us is that the atom was composed of tiny particles, and they were negative in nature, but the atom itself was neutral. So eventually there had to be a positive that was found. He concluded that all atoms must contain these negative particles. And why all atoms? Because he tried many different gases, and all of them tend to have this particle. And like I said, it's no net charge. The atom is neutral. So therefore, if there was a negative, it had to be balanced out with this positive charge. And basically how he does is the plum pudding